So we took a look inside the proc-ps-ng package, and we could see that commands like the ps command, things that we use all of the time, are a member or come from this package. And we can use the rpm command to be able to query our package management database. And if we use rpm-qf to query a file and query then /usr/bin/ps, we see that ps does indeed belong to this package. But we could also go through and list the complete content of the package. So using rpm-ql proc-ps-ng, we get a listing of everything that's included within that package. Now we can separate things such as configuration file and documentation. So instead of the L, we can use C and D. However, we can't explicitly separate out our binaries. So if we want to see all of the programs that are within that package, or at least those programs that will fall within usr/bin, then we can go through and list the complete content of the package, but send or pipe the information through to grep and look for the line beginning then /usr/bin/, and of course then that's going to list binaries below that directory that belong to the package. So some really useful tools that we can start looking at almost in a just-in-time knowledge. We haven't covered our software management, but each little bit we have to touch on in little sections. You'll see later on within this course we will look in more detail at our software management. The first commands that we started looking at were the pmap and the pwdx command. So we're using then the $$ variable to represent our currently running process, and we can see then the memory map, what's being used by the process. And we could see things such as obviously the bash shell we were running, but also the modules, the shared library modules that bash was using within the shell. We could use pwdx to get then the working directory of a process. And obviously if we look at things like $, it doesn't really help because we might as well just use pwd and don't worry about any options, because of course it's going to be our working directory. However, we could then go through and check other processes, and for other processes that we don't own, we're going to have to use sudo. And here we saw what we saw in the demonstration, just going through and showing the working directory for all of the processes that the SSHD is using. We started looking at the uptime command and tload and saw how useful especially tload could be. Uptime itself would read from the file /proc uptime, which displays then the uptime in seconds along with the idle time. Don't forget though that the idle time very often will be more or larger than the actual uptime in seconds, and that's because it's going to show the idle time for each CPU. So as soon as you start having multiple CPUs and getting towards the values of, let's say, 8 CPUs, we're going to start getting quite large values in that second column. Uptime also reads from the load average file, and again we took a look inside that load average file. But if we were also wanting to see the output of uptime reading from those files, then we can use the command w. That again comes from the package of proc-ps, but w just shows who's logged in, a little bit of the CPU utilization, but also the output of uptime at the first line. If we needed to run uptime over several instances, we could then watch uptime, and this would then run uptime every 2 seconds. If we needed to specify the interval, then we can use watch -n and specify the interval number after the option -n. Now if we really do need to concentrate on our load average, then we can use tload, which is going to produce an ASCII art graph for us. So it will display the values but also start building a graph, and we could see our graph growing as we increased our CPU utilization. So we saw that we could go and use tar to go through and create a backup and have that backup compressed. And we really saw how much load that was putting on the CPU, our single CPU. So tload was really, really useful. Remember, it runs then continuously, so we can then use Control and C to jump out of it. Now we've already seen the use of top so far, but we saw how we could use top within batch mode, so we could then just go through and run, say, one iteration and have that information then maybe saved through to a file even. With VMstat, we can go through and start displaying our units in different sizes. The default will be in the kilobyte format for memory, but if we use lowercase k as our unit of size, it will show it in kilobytes, so the 1000 rather than the 1024 measurement. When we look at it like this, we're running it then in megabytes, and we're seeing then that we're going to run 3 times with a delay of 5 seconds between each run. So in this way we can start gathering real-time information about what's happening on our system based on the memory, the number of processes, the CPU utilization, and we can have it collected and sent out through to a file, and maybe collect it, maybe not every 5 seconds, but maybe even every 600 seconds or something like this, so every 10 minutes. We'll be moving on now though to the sysstat package. If we really do want to collect information over a period of time, we should be looking at sysstat, and there are 2 S's in the middle of that package name. So do join me for that module, because you're going to get some great information on monitoring the performance of your system and documenting the performance of your system using sysstat.